This is a Unity scene running on a real PlayStation 2. It started as a simple exporter and somehow turned into a full-on retro game engine project. The goal was to take modern scene data and export it to run on old hardware. The PlayStation 2 is just the first console that I got working. Right now, it's basically a glorified scene visualizer, but even getting this far was way more work than I expected. I've always been obsessed with lockdown hardware. The Xbox 360, mobile phones, the PSP, whatever I could get my hands on. My first ever programming project was done using J2ME, which is Java 2 Micro Edition. That was way before Android and iOS. That 3 billion devices run Java that you see when you're installing it? Most of it is J2ME. Pretty much every phone from 2002 to 2010 had some kind of J2ME support. Me, as a young kid with her N-Gage, absolutely flabbergasted by the amazing 3D graphics, I wanted to make a 3D game of my own. And I did! Back in 2007, documentation was scarce, even more for a kid that didn't know how to speak English. Also, the only phone that could actually run my game was my grandpa's N73, and my grandpa was very angry. 3D support back then was basically non-existent. The code was written in Java. I was 12, so I had no idea what I was doing, but I wanted to make a 3D game that could run on a phone. The end result is on screen. It actually worked. Well, mostly. Pro tip: if you don't know how to swap back to the menu screen, just crash the game. It doesn't really matter, that works. Side note, I actually decompiled the code because I really wanted to see what the hell did I write, and the crash is actually in Stack Overflow. I have no idea, I didn't even know what that was back at the time, but I know I got a method that I just ran and it recursively called itself, so it just Stack Overflows. Also, I just added a one big enemy at the end of the level, so when you got there, the game crashes. You have no way around it. It was amazing seeing code that I had actually written running on a mobile phone. Like, it felt like I was doing something illegal. Later on, working with the Xbox 360 was amazing. Microsoft basically allowed you, if you paid $80, to develop on your own Xbox 360. So we had the XNA framework that basically allowed us to write C# code and run it on our Xboxes. You also had access to an avatar API, so you could use the avatars for each user inside the games. In my first ever release game, Falling Down, made great use of that avatar API because it solved the problem that was really hard for me at the time, which was actually getting animated models in engine. Hell, back then I spent months just getting a physics engine that I didn't even write it. It was called JiglibX. I got it on a website, I think it was called Project, doesn't even exist anymore. And actually getting it to work took me months. And this might sound like something very stupid coming from 2026, now with Unreal and Unity, and I already sound like a grandma, but back then if you wanted to have animated models in your game, you had to code a mesh preprocessor to read skinning data for each bone, create an intermediary format to store the model structure with the additional vertex data, code custom shaders that could handle all the data provided by the model, which usually meant each vertex had to be multiplied by 4 matrices by bone, so that was basically insane. I didn't even know matrix math back then. Code the actual animation player to play the animations. Oh, and that doesn't sound blending. If you want to play from run to idle, the animation would just crash in most libraries, so you had to do crossfading, which was insane back then. You basically had to crossfade between animations, so that was matrix slurping, which was absolutely. So layer of animations, playing 3 animations at once, changing legs, then arms, oof. No, not ever. And there was a library for it. It was called SG Motion, but it only released for XNA 3.1. There was no version for XNA 4. I actually had to rewrite it by myself just to get it working, because you could not submit games on XNA 3 anymore, just 4. So that was a whole hell just to get animated models. It seems weird because now it's just a little checkbox. Import animations, import skin. That's it. It's so easy now. And let me remind you, this is 2009. I had access to the internet, I had access to forums and discussions, and my English wasn't great, but I could read it. Imagine things back in the 2000s. I find that time from the PlayStation 1 to the PlayStation 3 so interesting because the hardware was incredibly more powerful than what the programmers of the time could even do. They were doing miracles without even knowing what the hell they were managing. Like, for example, this video from KZ64 where he gets Super Mario 64 to run like native hardware at like 4x the performance. That was absolutely insane. or even now the now abandoned Portal 64 project. Seriously, fuck whoever sent the cease and desist. I was hoping to play this game one day. I'm a believer that these old consoles can achieve so much more, but they were kind of stuck, and we're starting to see that a lot now, like with GTA 3 on the Dreamcast, like so many insane projects, and I want to be a part of that. And the PlayStation 2 seemed like a good starting point. It was my favorite console. It accompanied me from 2004 to 2008. It was my most played console. I was like, yeah, I wanna bring some new stuff. How it was done? It was not an easy fit, as the PlayStation 2 hardware has only 32 megabytes RAM, and it can even be smaller, we'll talk about that in a second, as opposed to the whopping 128 gigs that I have on my development machine. That's over a 4,000 times increase. It's absolutely insane, the hardware that we have at this time. So there was a need to develop two projects, a Unity C# project just to extract the data, and a project that was initially called PS2 Engine, which evolved into Helen Engine, and I'll talk about it more later. So starting at the PS2 Unity project, we have this lovely button, Export Scene. When I click this button, the library starts grabbing data about your scene. Every game object in the scene, every component, everything that's useful for the PlayStation 2 version is gonna be converted and serialized to a binary file. So, some quick knowledge about binary files. Binary is a good way to exchange massive amounts of data with minor performance impact and RAM impact. To better compare, today's web developers use a lot of something called JSON, which is JavaScript Object Notation. It's really useful, and I use it a lot. I'm not complaining about it, but it's not performant, not even close as performant as binary serialization. If you guys remember that GTA 5 bug that will take 90% slower, that was a JSON serialization bug. That's the kind of thing that happened that I just wanted to avoid. I don't want to deserialize JSON in a PlayStation 2. There's barely any RAM. We would be stuck with very small games, and I don't want that. I want high performance games. So the issue with binary is that to serialize binary, you actually have to define a file format. JSON, you just go serialized, and reflection just does everything for you. It just gets all the data and then it puts there. We could have ways of doing this automatically. Not really with this kind of hardware. We need to be hard code everything. So basically, how we handle binary files is that find a format which is linear. It's binary is not as hard as it seems. Like you see hex editors and all this macabre stuff. And it's just basically a list of values that you know what to expect. So basically, I start with a value which is 120. 120 means it's a mesh. After that, I write the amount of indices. So a mesh has vertices and indices. I won't get into this, but basically I write the amount of indices and then I write all the indices. So it's basically a deterministic format. If you read it, it would always go to the same linear thing, and we'll be able to read it on every hardware. And basically what I did was create two files, an assets.ps2, which basically contains all the assets in a linear format, and we reload all of that into RAM. So if there's more than 32 megabytes, even more than 4 because of the PS2 GPU, we could break it, but right now it's working, so that's good enough. The second is the scene. The scene basically contains the list of objects and what object to load. So basically, this is the mesh that I want in this object, this is a texture that I want in this object, and how we want it to load. It's here that I should point out that at the start of this project, I was already a programmer for a long time. I only had around 6 months of C++ experience. And it was the pretty Unreal Engine 4 C++, so I was not ready for what I was about to experience. And before adventuring myself on the PlayStation 2 SDK, I wanted to develop a version of the engine in DirectX. I thought it was a safer bet because I could just run on my machine, everything would be easy. Turns out it wasn't, but we'll see that in a sec. I'm familiar with C++, having dealt with some strange errors before, like this one time in Bandcamp. I was getting strange images out of my Unreal Exporter. Turns out the image pixels are RGB, and they were 8 bits each. When I tried converting a value bigger than 8 bits, like 256, instead of capping at 255, which in C# would just cap the value. In C++ it turns around, so 256 turns into 1. Or 0, I don't recall now. So that was giving me weird results, and it took me like 1-2 weeks just to understand why. And that was my biggest C++ achievement, but I was always scared of the language. So it was important to make the code as multi-platform as possible, as the Windows version was just a testing environment that basically had infinite RAM. All components have a base version that can be overridden by a platform-specific version, in this case DirectX, but later down the line we can have OpenGL and other platforms, which is my intention right now. Now, I almost lost my mind with a very specific DirectX bug. I could not read vertices from a file, only constant values work. We tried over 20 different approaches and nothing worked. Reading to a stack allocated array worked, but that will limit me to reading the vertices in chunks and make my life hell. I won't bait you with an amazing conclusion because there is none. It's just solved by itself. I am still not sure what happened. I want to investigate better later, but right now it works. And I hope it never comes back to bite me in the butt. I actually had to download RenderDoc and Pix and do analysis of what was rendering, and I still have no clue to actually understand what happened. But with that out of the way, I basically had a Unity scene rendering out of the editor. That code, it was time to look at how I would run my code on the PlayStation 2. I would say it's not as bad as the Nintendo 64, not even as limited as the PlayStation 1, but still the platform has a ton of quirks. I was prepared to have to code at dawn when I found this engine called the Tyra engine. It basically already had a library of shaders, and shaders have a very custom language. I couldn't even explain it, it's very weird. It's not shaders actually, it's called VU, it's crazy. And I didn't want to learn that at the start. I wanted to get something before I actually dive deeper. I wanted to say it was a very hard process, but because of Tyra, I had it running in less than 2 hours. My past experience working with multi-platform led me to designing a system that was basically very easy to edit. I had a render manager system that I had one version for DirectX, and I did one just called Tyra Render Manager, which basically created the buffers to render on the graphics card and everything like that, so that was very easy to do. I'm curious about what's gonna be the challenges to develop and support the PlayStation 1, but that's also another thing for another day. There were issues like the x-axis was flipped, and I had to do some math there, but it's also okay to handle. And now it looked okay, but it could look awesome if we got the light maps from Unity exported as well. A few years ago, I was a developer for Janus VR, which is a really awesome application that allowed you to write objects inside HTML and basically make a website, a 3D website. My function in the company was handling the Unity and Unreal exporter, so I had a lot of experience with extracting data and converting it into our format. With that knowledge in mind, and the actual source code because it's open source, so thank God for open source, I started porting the light map code for the PlayStation 2 so I could actually get the full lighting in the PlayStation 2. Just as a sample, this is Marcus Phoenix model from Gears of War. This is the tanks from Unity. This project is open source and is available on GitHub. The current version is not open source yet because I want to get it actually working before I start releasing the code to the public. And I want to establish a Patreon and everything else, so this will be pending. What's next? This was 3 years ago, I think. I actually took a lot of time to make this video, and I'm sorry, I'm now better of my head. I'm medicated now, I'm feeling good. And I had lost my hype due to all the licensing issues with Unity, and that's why also I had this idea. I was like, I want to avoid Unity. I want to make something on my own. That I don't want to depend on Unity for this. I don't think it makes sense. So that's how I started an open source engine, which is cutely called Hell Engine. Which basically the idea is to support retro consoles. The idea is to start at the sixth generation, so PlayStation 2, GameCube, and Xbox, all the way to Xbox 360, PlayStation 3, Wii, maybe Xbox One, PlayStation 4, possibly PSP, Nintendo DS, 3DS. If we're lucky, PlayStation 1. So this will be a community project because I won't be able to understand everything, even with AI tools or everything else that I could take my hands on. That this will be way too much of a mountain to climb. So this is something that I'm very much in love with developing. I love developing engines, and I really want to get this done. It's been so much fun doing this, and I would abandon, if I could, I would just abandon everything to work on this. For the full version, I have ideas of how to do everything else. The biggest trouble was running C# in these old consoles, but there's actually an out project called DNTC, which basically .NET transpiler, and the guy got it running on these NES. So that is actually very good because this NES has basically no RAM. So that could be our way out and actually get dynamic code running. I really hope this project helps the homebrew community, and I'll be working on it in parallel, even if I can't leave my job at the moment, but I will be working on it, and I hope I can help the homebrew community develop some crazy project. If you want to support the development of this and other crazy stuff, I've been working on a Batman full mod for Arkansas Island that subtitle scaling support with internal graphics options. I'm basically doing mods for a lot of different games. I'm working on a lot of different tools. I have some big projects incoming. I've been doing a lot of things in parallel, and I just want to share this with the world. Everything that I do is open source that I can, and that I won't release it at the start, but I will release everything eventually open source. Thanks for watching. Bye bye.